Hi, my name is Robert Agnew. I'm the CEO of TruSpin Nanomaterial Innovation. TruSpin is a developer of nanofiber production technology, and nanofibers are just what they sound like. They're extremely small fibers. So because of their size, they have special properties that help them solve complex industrial problems, and they can also enhance the performance of already effective solutions in new and exciting ways. So Invicta Water's approach to PFAS removal and destruction is a great example of that. Their catalytic crystals are already proven performers, and they're about to go into their first pilot line, a wastewater treatment facility in North Carolina. So the need to capture and destroy PFAS doesn't stop at the wastewater treatment facility level. There are still millions of Americans that pump their water up from wells in rural communities, and as the public's awareness of the problems with PFAS continue to grow, the demand for consumer level solutions is going to far outpace the rate of adoption of cleanup methods at the municipal or water treatment facility level. So you're going to see some under the sink solutions, or even things like improvements to the filters inside the ubiquitous Brita filter, for example, pitcher concept. So the size of the global total addressable market for consumer level water filtration devices is $50 billion a year. So TruSpin's nanofiber production technology helps Invicta Water's technology address these problems in some exciting ways. One of the key differences between these types of solutions and the big wastewater treatment facility up here is the wastewater treatment facility has a lot of highly engineered systems that can move massive amounts of water around in really precise ways. On the other hand, consumer level water filtration tends to rely on a lot simpler technologies. It tends to revolve around filtration membranes, and most filtration membranes consist of a fibrous media. So I'll draw an example of that. So most of the time, fibrous media consists of microfibers. Now, Invicta Water's catalytic crystals are very small, and they're not in fibrous form, so they would have to be embedded in the fiber. Well, if you were to do that with a microfiber, for example, here's what that would look like. The fiber is just way too big. All right. So you would wind up not allowing the catalytic crystals to get a whole bunch of exposure to the water that's flowing through the filter, because they'd all be contained inside the fiber for the most part. But if you put the catalytic crystals inside a nanofiber, nanofibers are much smaller than microfibers. They're on an entirely different scale of measurement. Microfibers are going to be millionths of a meter. Nanofibers are measured in billionths of a meter. So you wind up with this effect. You get the catalytic crystals, you give them a lot more exposure to the water that's flowing through the filtration membrane, simply because the fiber is so much smaller that it allows, there's just higher probability that the catalytic crystals will be on the surface of the fiber. So TruSpin is pretty unique in that we're the only company in the world that has this specific type of nanofiber production system. And one of its advantages is that it has a very high tolerance for massive amounts of additives to be put into the materials that become the nanofiber through our technique. Other production methods are much more temperamental and imprecise, and they can't really achieve this effect. So in a way, TruSpin's technology is an enabler for Invicta's already very effective solution to target this huge market. It's something we're very excited about. We're delighted to be working with Invicta, and we're very excited about the future. You can always contact us anytime, TruSpin.com, check us out. Thank you very much for your time.